Hello, my name is Thomas, and I'm an Android developer relation engineer working on machine learning. Today, I'm going to talk about the latest developments of machine learning on Android. I will show you how you can benefit from our latest offering, and we will see new ways to apply on-device machine learning as mobile devices become more powerful. On-device machine learning has advantages over processing data on the cloud. First, it enables low latency by eliminating a round trip to the server. It also lets you process the user's data while you keep them on the device. And you can provide your feature offline, since you don't need a connection to a server to run the inference. Finally, by running the inference locally, you will reduce your cloud bill. Let's take a look at a couple of experiences enabled by on-device ML. First, the new Lens AR Translate experience is a perfect example of the benefits of on-device machine learning. It uses a model to predict the pixels behind the removed text, allowing it to recreate the image. So the translated text appears seamlessly integrated as if it was part of the original picture. Here, the low latency enabled by running inference on the device is key. Second, the Android team in India is creating a solution to digitize important documents by scanning and extracting its key information. It leverages MLKit on-device text recognition API and other on-device ML classification models to classify the documents, example in this case a passport, and extract key fields. All of this processing is done on device. Today, you have two options to add machine learning on Android. First, MLKit. It's a great way to start. It offers a broad range of ML use cases packaged in simple APIs. Now, if you have ML experience and you created your own ML model customized for your use case, then you can use Android's custom ML stack. Built on top of TensorFlow Lite, it enables you to deploy ML-enabled features on Android and keep control over the inference process and the user experience. We have exciting updates to share for both MLKit and Android's custom ML stack. Let's start with MLKit and hand it over to David.
Hi, I'm David, Product Manager for MLKit. As Thomas said, MLKit enables turnkey ML features in your app without needing ML expertise. Let's take a look at what's new for MLKit. Over the last year, we have updated some of our existing APIs. By improving model performance, for example, we increased barcode performance by 17%. By delivering many of these APIs via Google Play services, so you don't have to bundle them and increase your APK size. For example, text recognition is now available in 5 scripts via Google Play services. And by adding new functionalities, for example, gesture classification in digital ink. We also constantly work on new APIs. We launched last year Face Mesh in beta, a very fast model optimized for selfie-style capture for applications such as video conferences, AR, or selfie upload flows. And we are working on a new document scanning API. Let's take a closer look at some of these APIs. For barcode, we did not only improve the performance of our model by 17%, but we also added a new option for you to use a UI flow provided by Google, instead of you having to build your own. This is Google Code Scanner, and we just moved it from beta to GA. With Google Code Scanner, you get access to a high-quality flow powered by Google Barcode Model and a provided UI that is consistent across the ecosystem. This flow is delivered via Google Play services, which has low APK size impact and you can use with only a few lines of code. Finally, this flow helps increase user privacy. Once you trigger it, the user points at a barcode and the flow only returns the barcode scanned value. Given you're not processing the image or the camera, you don't need to ask for camera permission, which results in more privacy and safety for the user. We also brought a major improvement to our text recognition API and launched it via Google Play services. Now, you can extract text from images not only in Latin languages, but in 4 new scripts: Chinese, Devanagari, Japanese, and Korean. Together, these scripts cover over 100 languages. We also improved the model latency and accuracy, and added some new features. You can now get the confidence score, the rotation information, and recognition at the symbol or character level versus previously only at the word level. This can be useful, for example, in Chinese, where a character can be a word. Last but not least, I wanted to talk about a new Android API we're building called Document Scanner. Digitizing physical documents is a very common user flow. Users turn to their phone to digitize, store, and retrieve important documents. For example, scanning your lunch receipt, your vaccination card, your children's homework. However, there was not a Google solution for this, and each app has had to build its own, which led to fragmented user experiences. That's why we've built a high-quality flow that can be used consistently across Android with a provided UI. This flow is delivered via Google Play services and is very easy to use. You can trigger the flow, and the user will be in control of scanning their documents in automatic or manual mode, cropping them, adding filters, and then sending them back to your app. And because it's done on device and the user decides which files to send back to the app, you don't need to ask for camera permission. We will be launching this flow later this year in Q4, but wanted to give you a preview today so that you can start thinking how to include it in your app. With that, I'll hand it over back to Thomas.
Thanks, David. Let's now talk about how to integrate your own custom machine learning model to your Android app. We heard your feedback, and we know that running custom ML inference on Android can sometimes be challenging. You have to deal with a vast ecosystem of devices, and identifying the best acceleration configuration for your model can be difficult. So today, I'm going to talk about Android's custom ML stack, a suite of components to make development of custom ML features easier and faster. First, we integrated TensorFlow Lite in Google Play Services as the official inference engine for Android. Second, we invested in hardware acceleration delegates to easily leverage GPUs. And finally, we created a new API to help you find the optimal hardware acceleration configuration for your model at runtime, the acceleration service. I'm very excited to share in details the progress we made. Let's start with TensorFlow Lite in Google Play Services. TensorFlow Lite in Google Play Services enables developers to use TensorFlow Lite for Android without having to bundle it with their application. As a benefit, the application binary size will be reduced by up to 5 megabytes. And as the new stable versions of TensorFlow Lite are fetched by Google Play Services, developers will benefit from performance improvements without any code changes. Finally, TensorFlow Lite in Google Play Services is the official machine learning inference engine on Android, which means that new APIs and services from Android's custom ML stack will be built on top of it. Since its launch in September last year, we've seen strong adoption. Today, it is serving more than 1 billion users monthly, and tens of thousands of apps are relying on it. Let's take a look at some of them. Internally, Google is actively leveraging TensorFlow Lite in Google Play Services to solve technical problems that didn't have a solution before. Have you ever ordered a rideshare that arrived on the wrong side of the street? The smartphone's GPS accuracy tends to drop in dense urban areas where the device doesn't have a direct line of sight with the satellites. Project Blue Sky, used in Android 8 and above, uses machine learning and 3D building representations to model effects of the reflection and increase the accuracy of the GPS in urban canyons, and, for example, solve the wrong side of the street problem. TensorFlow Lite in Google Play Services is also used by Android developers outside of Google, such as Wise. Wise is a UK-based company operating globally, enabling cross-border payments. Wise used TensorFlow Lite with Play Services to streamline the sign-up process. As new users take pictures of their identity documents to open an account, Wise custom ML model can evaluate the quality of the pictures and provide instant feedback to the users to properly frame it or to take a less blurry shot, for example. Verifying users' identity is one of the biggest costs for Wise's business. So ensuring users are verified easily and on the first attempt not only provide a great experience, but also decreases the costs for Wise. The MLKit team at Google also uses TensorFlow Lite in Google Play services internally. As a consequence, many Android developers using MLKit SDKs such as the barcode scanning API, language identification, or Smart Reply are also indirectly relying on TensorFlow Lite in Google Play services. Last but not least, it is also used by Stripe, a payment infrastructure company. They built an open source SDK for identity verification. Stripe runs two different image classification models to check the user's ID document and to validate the quality of a selfie, confirming the user's identity. By switching to TensorFlow Lite in Google Play services, Stripe reduced the size of the already very well-optimized SDK by about 1.2 megabytes. If you want to integrate TensorFlow Lite in Google Play services, the API is almost the same as the bundled version of TensorFlow Lite. So the migration should only require minor code changes. To learn more about it, go to the TensorFlow documentation on tensorflow.org. Now, let's talk about hardware acceleration. In general, app developers don't really need to think about which chip is going to execute their code. Most of the processing happens on CPU, to the exception of graphics rendering handled by the GPU. It is different from machine learning features. Indeed, ML inference strongly benefits from leveraging the specialized chips such as GPU, the DSP, or the TPU for Pixel phones. We call it hardware acceleration. In testing a pose detection model on Pixel 6, we noticed that the inference was 180% faster on GPU than CPU, and up to 200% faster on Pixel 6 TPU, freeing up your CPU for other features. TensorFlow Lite delegates are integrated with TensorFlow Lite in Google Play services, and they are the best way to implement hardware acceleration in your app. Both the GPU delegate and the NNAPI delegate to support some DSP and the Pixel TPU are available via Google Play services. Like for TensorFlow Lite in Google Play services, you don't have to bundle them to your application and increase your binary size. And you will benefit from auto updates as new versions of the delegates are published without code changes. We are also actively working with hardware partners to bring more delegates to Google Play services. So to learn more about acceleration delegates and how to integrate them to your application, go to the documentation page on tensorflow.org. As we saw before, hardware acceleration can dramatically improve inference performance, up to 10 times faster in some cases. And as a consequence, it can significantly improve the user experience of your ML-enabled application. However, identifying the right hardware acceleration configuration for each device is challenging, given the variety of hardware on Android. The acceleration service is a new API built on top of TensorFlow Lite in Google Play services that enables you to pick the optimal hardware acceleration configuration for each device. Here is how it works. When the user opens your application for the first time, you will call the acceleration service API and pass your ML model, some sample data, and the expected inference results. The acceleration service will then run an internal ML inference benchmark with your model and data sample on the chips available on device and return a performance report and a hardware configuration recommendation that you can directly apply to your TensorFlow Lite interpreter. Today, it supports the inference on CPU and GPU, and we will be adding support for more chips in the future. As mentioned earlier, the acceleration service is already available in beta. So if you want to benefit from hardware acceleration without having to worry about latency, stability variation, we strongly recommend to give it a try. To learn more about it and integrate it to your application, go to the documentation page on tensorflow.org. We covered a lot today. To summarize, if you want to add ML features without having to worry about training your own model, start with MLKit. If you have a custom ML model or you want to control the inference process or the user experience, then take a look at Android's custom ML stack. We can't wait to see what you'll build. ML on Android is constantly evolving. So to continue learning about it and stay up to date, visit d.android.com/ml. Thank you.